I will give you a warning shot today of what I mean by exit cards, and expect an exit card. So Indy's not here at the moment for me to tell her, but not pup exit cards. You will have an exit card every day that you do not have a test. So your Iris is now looking panicked. It's okay. So today's I will show you what I mean, and it will be a trading grade. But then Tuesday, you'll have another exit card, and that one's going to be real. Wednesday, there's a test. Thursday and Friday, another real exit card on each of those. And then Monday and Tuesday, the week after. That makes 5 exit cards.
Oh.
Okay, hold on. Don't ask questions before I'm finished. Ray, turn around. So that'll be 5 exit cards. I will drop the lowest one. If you are absent, that is the one that's dropped.
Even if it's live.
Yes, if you are absent, you are not in class to take it, then that is the
sometimes it's unavoidable due to like the doctor. So could I make that up? Like I don't know.
Nope, that's the one that would be
Before the
dropped.
fact.
I'll slide
Please.
it.
You missed 2.
If you miss 2, then I will make your life hell. But yeah.
I'm giving a review day for the guys.
Yeah.
Will there be an exit card on the review day?
Okay. I want to do this now. So we just a heads up, there will be exit cards each day, and together they add up to their own little quiz of review. So tell Indy what we just said.
There's an exit card every day.
So it's not a surprise pop exit card. You're gonna have exit cards every day.
Fun.
Yay! Pep rally.
Are there any like in chronological order of the content?
Nope.
Oh.
So the one today and the one on Tuesday will be related to things on chapter 5. However, the ones for the days after that are on the midterm review.
What happens if you like miss class?
If you are absent one day, that is, so Liv, you weren't in here. There will be 5 exit cards. The lowest one will be dropped. If you are absent one day, that is the one that is dropped. Okay. Yesterday we learned a couple quick ways. Natalie, is it content related?
Can you make the thing bigger?
Maybe. Okay. We learned a rule of like this thing means integrate. Sorry, Walt, give me a minute.
No, you're good.
How do I integrate that? We learned a rule yesterday. Undoing antiderivative by doing what?
Adding power and dividing by.
Okay, so undoing power rule, because it's just a regular old polynomial. Regular old power rule. So she said raise the power. The power was what? 1, so I'm going to raise it to 2. That 2 was there. Divide by the new power. There it is integrated. These numbers, this thing is called a definite integral. If there were no numbers there, that would be my answer. Raise the power, divide by the new power, and don't forget to add that constant. Amalia?
Do you not simplify the fraction?
Sure. Simplify the fraction. So one of the fundamental theorems of calculus is, well, you know what? I had numbers on this, and I integrated it. And here's the process. This squiggly thing, now that I have done squiggle, I've done integrate, it's going to move to the other side. It's going to become straight. And I'm going to do that. So I keep these numbers. So Ray, it's just the process. Okay, what happened to the constant? It's going to go away, and I'll show you in a second. Why is there a what?
Why is there 2 next to x squared over?
Because that's what the problem was given in the first place.
You need to raise to the power and then divide it. This was already 2x.
And Carson said, what happened to the plus c? All right, I'll put it in. The way we evaluate this with a thing called the Fundamental Theorem of Calculus, which we did not finish yesterday, but here is the process. This is what it is. I'm going to plug this first top number in, bless you. I'm going to do 3 squared plus c, plug the top number in, and I'm going to subtract, plug the bottom number in, which is -1 squared plus c.
What if you this? Oh,
Okay, so in parentheses, like all this junk with the 3 plugged in minus all that junk with the -1 plugged in. So I get 9 plus c minus -1 squared is +1, but I was subtracting it, and then I need to distribute to that c. So Carson, what's going to happen to the c's?
Yes, well.
So this whole thing becomes 8. So if there's a definite interval means I'm asking you for the area under the curve in this space, specific numbers. I'm giving you the time window. Find that area. Cool. Don't need to add plus c. If there is no number written on them, you need plus c. All good? Okay. Liv, no? Isaiah, what's your question?
So how would you write that?
How would you write?
After you get 8, you have to write your final answer. Is the 8.
Okay, so really all the work I would do with this, I would raise the power divided by the new power, and I would reduce all at once. I would do that straight bar, and I would say 9 minus 1 equals 8. Done. Like, that's the work that I would show.
So if there are numbers, do we have to put plus c?
Because if you did,
Just
it was plus c, and then it distributed, and don't bother. Okay? Okay. So we did all of these yesterday. Just to remind people, integrating x to the n dx, what was that as a pattern?
x to the n plus 1 over n plus
And then
1 plus c.
And then there was one that was a special exception. Isaiah, what was the special exception? So n can't be -1. All right, what is n when it's -1? Well, raise the power, divide by the new power, raising -1, adding 1 to it is 0, divide by 0, problem. But there is a particular thing that has this as its derivative. What was it? Natural log. And you need the damn jail bars, okay? It's natural log of absolute value because you can't do natural log of a negative. We did this one also. Ryan, whose derivative is positive sine?
Positive sine, negative cosine.
Good. Negative cosine, and don't forget plus c.
Plus c.
All right, Josh, whose derivative is positive cosine?
Sine.
Positive sine or negative sine?
Positive.
Positive. Oof, that says sine x plus c. So a lot of integration so far is, do you remember the derivative? If not, we're in trouble. Because do you remember the derivative? Hey, that's this guy's integration. All right. Why these are negative, I don't know. So, no. Let me fix one thing. You guys just write those down, the things in that little box. I will make it bigger, Isaiah. Promise. Give me a second. Maybe not that big. Can you still see it, Isaiah, or not anymore? Not anymore. Enough?
What is this? Like, what do we?
Just copy these patterns down here so I can.
We did very well. You got inside. Oh, no. That would be worse.
No. Okay, so the first two really you need to have memorized. The second two, once we get to use substitution in section 6.3, this ought to be easy enough to do without it. And I have never, ever seen the bottom two used. I'll just write it down for grids. Yes.
Wait, so does will the C ever matter, like when we're plugging in the numbers?
When you plug in specific numbers, when it's a definite integral, no, the C does not matter.
Because it's like that doesn't change the area, just when we have the noun. Or
So when you have an equation and I tell you, find the area there, it's specific. Like you can paint it in and be like, I can calculate this area. When I don't tell you where we're integrating from, you don't have that specifics. It'll make more sense in a couple of sections. I was gonna say not days, but more sections. Should you need to actually know these, what's the derivative of tangent again, Lanham? Do we remember?
Is it cosecant squared?
Close. Secant squared. Tangent, okay. Tangent goes with its friend. Oh. It is not wrong as written. It is wrong as written. Can you guys put a negative on that one? I changed one thing and I didn't change the two things. It's negative natural log of cosecant x.
So cotangent.
The integral of cotangent.
Why is there like the absolute value sign there?
Because you cannot do the integral of a negative. Or, sorry, natural log of a negative.
Yeah.
They're just there. So tangent and secant in these Pythagorean identities, hopefully you know sine squared plus cosine squared equals 1. And then dividing everybody by cosine squared, we get the first one. Dividing everybody by sine squared, we get the second one. Like tangent and secant go together, so that's a way to remember the derivative of tangent. his buddy is secant, secant squared. And then cotangent, the derivative of cotangent, I normally write these as all the derivatives of the one with c have a negative. Cotangent hangs out with cosecant squared. They're a little contrary, so they're negative. Secant is a jerk, puts itself in its own derivative and brings a friend. Which friend? The one that's here. And cosecant, also a jerk, puts itself in its own derivative and brings a friend. Which friend? Cotangent. So if you can remember those, the integral of tangent, the power goes away, but it's natural log of secant. This one, the power goes away, still negative, natural log of cosecant. And this one, the product became a plus. And I've never, ever seen these two used. But just write them down in case, it bites you in the butt on the exam. Mikhail, pick B. Yesterday it was C, today it's B.
Can you explain why you changed, like mathematically, why you changed the sine x to cosecant x and then made the natural
Okay.
log?
So when I integrate this one, I'm going to get natural log of sine x plus c. And for the mnemonics, the way that I like to remember things, cotangent doesn't go with sine, it goes with cosecant. Okay. I'm going to bring that -1 that was supposed to be there in, sorry. So if I multiply everything by -1, this is 1 over cosecant x. But I can't just multiply by -1. I'm going to make it another negative, and I'm going to put the negative in here. So that I can have the cosecant and cotangent stuff go together, it's easier for me to remember this. Okay. All right. Fundamental Theorem of Calculus. There's a part 1 and part 2. The textbooks disagree which one is 1 and which one is 2. So your textbook is choosing to call this one number 2. We already had one brief experience with it today. If I can integrate, the way we evaluate it, the integral from A to B that's what we do. Like I showed you this as an example in the first problem. Yes.
The reason that f becomes capital.
Yeah. Okay. It's just convention. They're like, when we integrate, we're going to give it a different name because it's a different function. So we will try. Keith, pick a number. 1. All this, you pick 1. Infinite number of numbers out there, and he picks 1. Fine. 1. We will pick numbers that I can actually do. So with our undoing rules, Ray, what is the integral of 3x squared?
The 3/4 x over.
Raise the power by 1, so
Oh, to the third.
the power. So 3x to the third divided by 3. Okay, those guys are going to go away. Liv, what is the integral of -2x?
-2x squared over 2.
Those 2's go away. Cool. Tessie, what's the integral of just 1?
0.
raise the power. What power is on the x that's here? Yeah, I don't have an x, so it's x to the 0. So raise the power from x to the 0 to x to the 1. And that coefficient was 1, as Keith chose. Yeah, Nick.
Can you, I can't see the definition because there's that box in the way.
That is the oh, sorry, it just says antiderivative.
Oh, okay.
Okay, so here they found the equation that is my integral. So Ray, the capital F, it's not the same function, so they can't call it f, little f. So they're like, it's the parent function. It's bigger and badder. Capital F. So that's all it is. It's not the same equation. So I'm just showing you the process of how we now evaluate this. Can I? Not yet. Can't scroll off yet. So this pink example is the blue guy. Maybe f of x was this. Capital F is this guy. And now evaluating. So the fundamental theorem of calculus is now how we evaluate. Nico, I need to plug 3 into each of these. So what am I going to get?
You get e cubed minus 2 squared plus 3.
And then I need to subtract, plug in the bottom number. Okay, smart. I know it's a challenge, but plugging in 0, what do I get? I just get 0. So overall, there, you've done integration without having to do area under the curve, without having to do rectangles, without having to do trapezoids. We are just now applying undue power rule. Liv, what's your question?
Why wouldn't we if we add a plus c on every integration we do, why wouldn't we add a plus c?
Okay, already answered that today, but we will do it again. Plus c. Okay, ready?
Oh yeah, I remember this. All right.
So as Tamar said, and since we're recording, we will say it again. This was a plus c, and then minus distributing c minus c. I don't know what that means, but cool. All right. So, fundamental theorem of calculus.
No, which one's bad? Are you sick?
This is in your textbook. They are so sassy. They're like, you can often do it without any effort as long as you know what's going on. Thanks a lot.
You go with the squirt all the time. It's like,
Okay, so we already did this, right? A second ago.
oh, let's do this. That's cool. That's not
Cool.
that's cool.
Can you guys do this problem now? Brian? Yes.
Yes.
What'd you guys get?
I got a
That's true. Negative over losing calculus.
Yeah, I know. Okay.
Don't worry about it.
So,
Actually,
honestly,
yeah,
like,
32.
arithmetic is where you guys are going to start to make mistakes.
That's-
Like, you'll do the calculus right,
Oh,
but
mine.
1 minus 1 is no longer 0. Crazy business.
-1.
Raise the power, divide by the new power. However, this 3 and the new 3 cancel.
Okay.
It's kind of slow.
So plug it in the 3,
If you're adding some calculus, it's gravity.
plugging in -1. -1 cubed is -1.
Forgetting to add the 3.
And then another -1.
So it's
So what is it? 28 or 32? 32.
-1 minus -1. Oh wait.
Turn 2.
Oh, because the -1.
Yep.
Makes sense.
Minus 1 is -2.
Like from the.
Ah, okay. Well, first question. What is the derivative of x? Multiply by the power, lower the power. 1. So doesn't it make sense that if I integrated it, don't I get x back? Okay, but wait a second. Now, if this is 10, how does it integrate? Right here, 10x from over there. So whatever this constant was, we're going to stick an x on it.
So just for me, the constant times x.
Raise the power, divide by the new power. Yes.
If you, wait, you divide by the new power or you divide by the number in front of x?
Sorry. Raise the power, divide by the new power, not the number in front of x.
Alright, because that's what I was thinking, because otherwise it would just be like x every time, right?
Like I could still hear my calculus teacher saying this, raise the power, divide by the new power. Like in weird dreams, those words go through my head again. It's just twisted. Okay, so my alarm is about to go off to say you should start the exit card that is for practice to give you a
So we're just like screwed in a future, we don't remember this.
you're just screwed in the future if you don't remember what's going on. That's okay, so stop. Trade papers with someone, just so someone else has to read your handwriting. So this is gonna be a little bit fast because I want to make sure we go over it. So this first one, R prime, that means what is the rate of change? And we're asking you to estimate it. How do we estimate that rate of change? Okay, guys, this is saying what is the slope at 3/4? Do I have some coordinates around 3/4?
Oh, I'm sure.
Yes, no, yes, which two coordinates should I choose? So r prime of 3/4 is approximately the change in 1. So you need to use the two coordinates that are closest to this one. 3/4 is in between 1 and 1/2, between 1 and 1/2. So r of 1 is 17. R of 1/2 is 22. Oh, okay. Going on its own. 17 minus 22 is -5. Divided by half is really multiplying by 2.
That'll be the x there.
Can you describe that?
What actually write the correct word?
Like, wait, so we're trying to find the gallons per hour per hour?
I just want to write down.
I put in the.
Oh, but how is this?
Okay, hold
How
on.
is the gallons per hour minus gallons per hour giving us the gallons?
Okay, hold on. So the units on this, Carson said I got the right answer and I don't know why.
I did.
So, right, well, the rate, R up top was gallons per hour. What is this stuff in the bottom? Dividing by hours. So this is basically the acceleration of water being, or oil leaking out.
What is the math that we did? I don't understand this.
What is the math that we did? We just did slope. What is the rate of change at 3/4? I don't know. I don't have that specific value.
Yeah.
So I'm going to do what is the slope between the two numbers closest to that. Okay? RM with 4 sub-intervals. So rectangle 1 is RM. Choose the number on the right times dx. Rectangle 2, choose the number on the right times dx. Rectangle 3, number on the right times dx. Yay for rectangle 4, number on the right times dx. So using right rectangular approximation method, this adds up to 24. And then part C says the thing that you guys didn't like from Delta Math. In the context of the problem, what is your answer? So what we just integrated was R. R is the rate of oil that's leaking. So, does anyone have an answer? What would you say?
24 gallons accumulated in materials.
It's lost.
Kinda.
It's the amount lost.
24 gallons of oil. So, that's your noun. Hold up. We need a unit of time.
Over the 2 hours.
So, and is it an over or under approximation? Under because it's RN.